Hello, this video is for Bodhibana and it's from 2016, May, June, and it's paper 2-1 and it's question 5, as you can see. All right, there's a sequence. Complete the diagram to show the mechanism of this. This is obviously a nucleophilic substitution. And let me make it a bit bigger because it's a bit small to see the details here. Okay, there we go. All right, let's pick a nice red pen. First thing you've got to do is you've got to put the charge differentials on, so plus and minus. You've got to put your electrons on the nucleophile. Okay, and then this is going to attack this carbon there, and these electrons are going to go away. So you're going to get this, and the bromide ion is going to be released. Okay, 2 marks. Give the name of the type of reaction in 3. Well, lithium aluminium hydride is a reducing agent, so this is going to be a reduction. Let's move this up. There's an infrared spectrum of the propanoic acid shown by reaction 2 is shown. Describe the main difference between the infrared of W and that of propanoic acid. Now, W, because what we're doing is we're reducing propanoic acid, is going to be propan-1-ol, okay, primary alcohol. So 1, 2, 3. There's an OH. So as you can see, well, I think anyway, the main difference is it's got no carbonyl group. Now, while we're here, let's have a look at this. Let's break these down nicely. This group, around 3000, broad, it's quite broad that way, it's an OH. This one, around 1700, is a C double bond O. This one, around 1250, is a CO group. So this is a very typical carboxylic acid. You've got the carboxylic bit, this, you've got that bit, okay, and that bit, all right, and that bit, basically, this one, let me see if I can draw this. This one dings at about 1700, this one dings at about 1250, and this one dings at about 3000. Okay, so if I were to look at this infrared, I'd say, yeah, that's a carboxylic acid because it's got all 3 groups. Okay. Anyway, so what's the difference between that and propan-1-ol? Well, propan-1-ol will have this. It will even have this because there's a CO bond, but it won't have this. So the peak at around, I can't see exactly what it is, around 1700 will not be present in the infrared of W. Now, where did we get the 2 marks from? Well, this corresponds, you got to say this, corresponds to loss of the C double bond O. You can't say CO because CO could mean C single bond O or C double bond O. You got to say the loss of a CO, or you can name it the carbonyl group, yes? But you got to say it, all right? So where did we get the 2 marks from? Well, you get the 1 mark for saying what it is, and the other mark is for saying where it is. You got to do that for the 2 marks, okay? There we are. That one done. That's not too bad. Give the reagents and conditions for reaction 4. Oh gosh, which one's reaction 4? Okay, let's have a look. Reaction 4. We've got bromoethane to the alcohol. I think, yeah, that's what it looks like. So that's obviously going to be aqueous sodium hydroxide, isn't it? All right. So here we go. The reagent is sodium hydroxide. Now the condition is it's got to be aqueous because it's going to be a nucleophilic substitution, not an elimination. So it's aqueous and we have to heat it up. This one is quite easy. We just warm. Okay. Give the conditions for number 5. Let's have a look at number 5. Oh, I've missed it. Number 5. Oh, there you go. That is an elimination, isn't it? So conditions needed for that. Now it's going to be sodium hydroxide again, but in this time it's going to be a purely ethanolic solution. Okay, and this one takes a bit more effort, so we say heat for that one. All right, so there we go. So we need ethanol for that one. All right. Under appropriate conditions, ethanol and propanoic acid undergo a condensation reaction. State the conditions necessary. Now, conditions for this are we need a catalyst of conc sulfuric acid. it's the pure stuff. All right. So this has got to be liquid. All right. If you say aqueous, you're finished. So it's conch, that one, and heat, I'd say. I'm looking at the answer scheme, and it doesn't say heat, but I'd always put it in. All right. If in doubt, put it in. All right. Draw the skeletal formula of the product of the reaction. Now, I'm not very good at skeletal formulas, so I have to do it long way round. All right. So what am I going to do? I'm going to draw propanoic acid. 1, 2, 3. And there is the acid, and it's going to react with ethanol. 1, 2. Okay, so this is my effort, and obviously I can't keep it like this. All right, so now I've got to change it. Right, we've got 3 carbons on the left, so it's 1, 2, 3. Of the third carbon is a carbonyl group. There's an oxygen and 2 carbons here. 1, 2. All right, and that's it. That's the skeletal formula. Name the organic product of the reaction. Well, we should all know this by now. This is ethanol. That's the first name, so this is going to be called ethyl. And the acid is propanoic acid, so it's going to be ethyl propanoate. Okay, there you go. Now, this is the bit that Bodyburner actually wanted, but I wanted to do the whole thing. V reacts with acidified manganate ions, manganate 7 ions, in 2 different ways depending on the conditions. So hot, concentrated, we get that. Cold, dilute, we get that. Now, obviously, on the left, this is a vigorous oxidation. And this one is a mild oxidation. Okay. Now, this is interesting. I'm going to guess, all right, without thinking of it too much, that what is V? Well, the only product is propanoic acid. Okay, so I'm going to guess V is a symmetrical thing. 1, 2, 3, 4, 5, 6, with the double bond in the middle. Because this guy here, I'll try and name it in a minute. It's hexene, isn't it? Hexene would give me one product, propanoic acid, all right, because it would split right in the middle there, all right, and it would give me propanoic acid. All right, I'm going to guess that's all. Obviously, V is going to decolorize bromine, so let's pretend I haven't done this yet. V decolorizes bromine. Yeah, of course it does, because it's an alkene, and this is oxidation of alkenes, isn't it? When acidified manganate is hot and concentrated, propanoic acid is the only organic product. So it must be a symmetrical alkene, and we're right, aren't we? It must be this. All right. When the acidified manganate is cold and dilute, the organic product is that, which has 2 chiral centers. Give the structure of formula V and T. Now, structural formula. So it has to be some sort of structural formula. I'm going to give it like this. I'm going to say CH3. CH2, CH. Now, Cambridge, you can do that if you want, the CH. I personally, I don't know what you think, but I personally like putting the double bond in like this. CH2, CH3. And T is, well, T, let's draw T. Let's get rid of that. T is going to put an OH on either side of the double bond. So T is going to be CH3, CH2, CH, OH, CH, OH, CH2, CH3. Okay, maybe this is the one that that Bodyburner was having a problem with. I don't know. All right, but we'll see. All right. So there's that. All right. Identify the types of stereoisomerism shown by V and T. Well, V has a double bond there, and it will show cis-trans isomerism. Okay. Now the posh name for that is geometrical isomerism. But if you don't like that, you can call it cis-trans. That's fine. Now, T, where's T? It said something about chiral centers. T has chiral centers. They're in there. And let me see if I can... That one there is chiral. And that one there, they have 4 different groups around them. So the type of stereoisomerism there is optical. Okay, there you go. Let me post this now.